All right, 10.1. Whoa. Our objective to simplify and multiply radical expressions. No warm-up, we're just going to jump right in. Square roots are written using a radical symbol. You can see what that looks like off to the side. You should be familiar with it. An expression written with a radical symbol is called a radical expression or radical. Sometimes we also refer to these as taking the square root. The number inside of the radical symbol is called the radicand. So the symbol itself is a radical. The number, or it could be a variable underneath it, is the radicand. Anybody need more time on this slide? Okay. Simplifying square roots. Again, these properties we should be familiar with. The first property is that if you are taking the square root of a product, so in this case A times B, that's the same as if you were to take the square root of A and the square root of B separately and then multiply them together. This property does not hold for addition or subtraction. So you cannot do this with adding and subtracting. This is only something you could do with multiplying, and I think we'll see later on dividing. So this is one way that we could make our lives a little bit simpler with this see how it works example. Instead of taking just the square root of 27, they split it up to the square root of 3 and the square root of 9, because 9 times 3 is 27. The square root of 9 simplifies to 3. The square root of 3 stays. So you can kind of see this square root of 9 becomes the 3 that's out in front. The radical 3 in the back stays the same. They just switched the order they were written in. Questions, concerns? Again, simplifying radicals is something we should be familiar with at this point. You don't need that second one. We'll just do the one, see how it works. We should be familiar with these, so that's why we might go just a little bit quick through these examples. When we simplify radicals, we do not use decimals. So a calculator might help for things like figuring out what the factors are, but we would not just put it into our calculator and write down the decimal that we get. So for this first one, we could do it a couple ways. The way that the last slide would want us to do it would be to break this up into the square root of 4 times the square root of 6, because 4 times 6 equals 24. And then the square root of 4 is really just 2. Square root of 6 won't simplify. Now, if you prefer to do this the way that you probably learned in Algebra 1 and that we did earlier this year, where you make a factor tree, I'm fine with that. Find your pairs, see what's alone. Remember, anything that had a pair, one of them came outside. Whatever was left over got multiplied back together and stayed inside. Who remembers this from earlier this year? Okay, good. We did this. If you were in this class last semester, we did it, I think, between chapters 3 and 4. So the square root of 75, again, if you prefer the factor tree, that's fine. I'm going to write it as the square root of 25 and the square root of 3, because I know 25 times 3 is the same as 75. The square root of 25 is 5. The square root of 3 doesn't simplify, so that is our answer. Again, if you like a factor tree, go for it. Questions, concerns, need more time on 1 and 2? We'll move along then and put up 3 and 4. Go ahead and try these on your own, and we'll put up the answers in just a minute. Again, if you want to do a factor tree, that's fine. If you want to write it with the square root of a perfect square and then times the square root of what's left over, that's fine too. What did we get as an answer on number 3? Anybody else agree? Get something different? Didn't get it done? It's Friday, so we don't know what we're doing. So I heard 10 radical 2 as a potential answer. I asked if anybody agreed or if anybody had a different answer, and I was met with silence. So I've heard one little yes. Do I need to come around and look at everybody's papers? Because I've seen most of you writing, so I'm assuming most of you got some sort of answer. Hopefully you agreed with 10 root 2. This could be split up into the square root of 100 times the square root of 2. The square root of 100 is 10. So 10 root 2 sounds good to me. If you did it with a factor tree and you got the same answer, that is perfectly fine. What about number 4? 3 root 5. Good. I heard a few more people answering that time. I would agree. Again, a factor tree is also acceptable. Either way you do it, you should get 3 root 5. Questions, concerns, need more time? On we go. So this is the same idea, we're just kind of going the other way. To take the product of square roots, you multiply the radicals and then simplify if possible. Thank you. So this time they were taking the square root of 2 times the square root of 7. That was the original problem. To do that, they multiplied the 2 and the 7. They got the square root of 14. Of course, that doesn't simplify, so it just gets left alone. This next one, if you want to write it down, might be helpful. They took the square root of 2 times the square root of 8. 2 times 8 is 16. But the square root of 16 can be simplified. It's a perfect square, so they put plus or minus 4. In this class, we won't deal a whole lot with the negative square root. We'll really just focus on what is called the principal square root or the positive square root. So if you didn't put the plus minus sign, it would be okay. Next year, when the majority of you, I believe, will be in Algebra 2, if you haven't already taken it, you will have to be more mindful of your plus minuses with square roots. Which, while we're on the topic, this isn't going away. You are going to see radicals that you have to simplify in Algebra 2 as well. I know that for a fact because I've taught it here before. Questions, concerns? Keeping it moving. I'll go ahead and put all of these up there. These first couple examples are not very exciting because you're not going to be able to simplify them. We've got a bunch of prime numbers we're working with here. So when we take 7 times 5, what do we get? 35. Oh, that's not what I was going to do. 7 times 5. So we can do all of that under a radical together. We get the square root of 35. That's not going to simplify because 7 and 5 are both already prime. So that's just all there is to it. Same thing on the next one. When we multiply 11 and 7, we would get the square root of 77. Again, 11 and 7 were both prime. There's nothing to simplify. Yes, ma'am.
Do you have to show like multiplying with a radical, or can you just like?
On these ones, you could just go to the answer. If there was simplifying involved, I would want to see work for that. But as far as this work goes, you don't necessarily need to show that step there. That's fine. Any other questions? Okay. Number 7, we get into a slightly different idea, but again, we did talk about this before. The 2 on the outside of that radical would get multiplied to the number that's in front of the other radical. There's no number written there, but we know that it's really a 1. So you could think about the fact that that's a 1 in front of that radical. And of course, 2 times 1 is 2. Stays outside. Anything that was inside gets multiplied together, stays inside. So 3 times 5 is 15. And again, 15 does not simplify. It would just break back into 3 and 5, which are prime. So that's our answer. So on number 8, when we started off, the 5 is getting multiplied by 1 again, which is a 5. 3 gets multiplied by 3, which is 9. This time, though, we can simplify. What is the square root of 9? 3. So this becomes 5 times 3, which is 15. So our answer is just a whole number. There is not a radical. Remember, it's possible for the radical to go away if what was under it was a perfect square number. Questions, concerns about 5 through 8? Is this all coming back? All these wonderful memories from Algebra 1 and first semester? All right, we've got 4 more to simplify. I'll give you a couple minutes to try these on your own before we discuss the answers. Okay, let's get these wrapped up. What did we get for the square root of 20? Crescencio? You're close. 2 radical 5. So, did you do it the factor tree way?
Oh, I see.
So we should have gotten the pair to be the 2s. So that's the one that goes on the outside. The 5 is all alone, so that stays inside. The other way of doing it, of course, is square root 4 times square root 5. You would get the same answer. What about number 10? 2 radical 2. Again, you could make a factor tree. 4 and 2, 2 and 2. Or you could do square root of 4 times square root of 2. 4 times root 2. Either way, same answer. Oh, just when I heard somebody pull on the door. All right. Next one. What did we get? Very good. On this one, we've already got a 2 on the outside. So that gets multiplied times the square root of 25 times the square root of 3. Or you could do your factor tree either way. Thank you. But the 2 and the 5 on the outside get multiplied together to a 10 square root of 3. Finally, number 12. What did we come up with? In my opinion, a factor tree is probably a little easier on this one. If it's an even number, you know it can be divided by 2. So 2 times what?
56.
Okay, another even number. 2 times 28. I'm going to have to start going sideways with it. 4 and 7. 4 breaks into 2 and 2. So we start looking for our pairs. Remember, if you broke a number down, you don't reuse it. So I would cross off any number that got broken down so I'm not tempted to go back to it. Cross them off. Okay, so we have a pair of 2s over here, a pair of 2s down here, and what's left alone?
7.
The 7. If we have 2 pairs of 2s, 2 times 2 is
4.
radical.
7.
Beautiful. Questions, concerns?